Let's talk about complex numbers before we start the actual lesson today, because it has to deal with complex numbers, which is another name for imaginary numbers. Complex numbers are written in the form of a plus bi, where a is the real part and b is the imaginary part. And b is a multiple of the imaginary part. So what I mean by that is an example of a complex number or an imaginary number would be the square root of -3. You know that we can't take the square root of a -3. So mathematicians have come up with imaginary numbers so we can find these solutions. And they actually can be graphed, which we're not going to do. So the square root of -3 would be the square root of -1 times the square root of 3. If you recall from Algebra 1, which you may not remember, you can multiply radicals. So the square root of a -1 times the square root of a +3 is the square root of a -3. Well, imaginary numbers, complex numbers, tell us that the square root of -1 is I. So if we have the square root of -3 and we break that down to the square root of -1 times the square root of 3, this is I times the square root of 3. We can't simplify that any further. Since complex numbers are written in the form of a plus bi, a is the real part, this is your real part, it would be the square root of 3i, and the I is not under the radical, and that would be the answer to that. That would be how you would write that. You may see it like this, and that's okay because multiplication is commutative, so I don't want you to get worried if you don't see it like, or you don't see it like this, but you do see it like this. So let's go ahead and try just a couple. If we have the square root of -9, we know that this is the square root of -1 times the square root of 9. You know that the square root of -1 is the imaginary part, and the square root of 9 is 3. So the way we would write this would be 3i. Let's do another one. The square root of -7. That would be the square root of -1 times the square root of 7. This is I times the square root of 7. So your final answer would be the square root of 7 times I. Again, the square root of -16. We have the square root of -1 times the square root of 16. The square root of -1 is I. The square root of 16 is 4. So our answer would be 4i. And the last one, square root of -10. That is the square root of -1 times the square root of 10. The square root of -1 is I times the square root of 10. Can't be simplified. So your final answer would be the square root of 10 times I. You may see them like this too, in parentheses, just so you know that this is separated. You'll see it a whole bunch of different ways. It's just important that you understand what this is actually saying. The real part is the square root of 7. The imaginary part is I. The real part is 3. The imaginary part is I. So why do we care about all of this? Well, if I have the equation x squared plus 10 equals -6, very basic quadratic equation. You know that we don't have to use the quadratic formula with this. We don't have to worry about factoring this. We can just move this constant term over to the other side. And if we do that, we get x squared equals negative 16 because we would subtract 10 from both sides. Well, trying to solve for x, we would get x equals the square root of negative 16. Well, when we were solving quadratic equations, we would stop here and we would say no real solutions. But now we know how to deal with negative square roots. And so we would say x equals plus or minus square root of negative 16 because you have the positive square root and the negative square root. So we have x equals plus or minus, we can pull out a negative 1 times a positive 16, and we can simplify this. Typically, you don't have to write it in this many steps. I'm hoping that you'll be able to see this with a little bit of practice. So it's a plus or minus I times 4, so we would write that as 4i. You may see it like this. You may see it broken down. X equals 4i or x equals negative 4i. Let's try another one. X squared plus 30 equals 6. We have x squared equals negative 24 because you would have to subtract 30 from both sides and you get x squared equals negative 24. We take the square root and we have x equals the positive and negative square root of negative 24. Can't leave your answer like that. So we would pull out square root of negative 1 times the square root of 24. So it's a plus or minus I times the square root of 24. So x equals plus or minus square root of 24i. I'll put parentheses around it. This actually can be simplified a little bit further. I don't want to worry about that right now. I do think later in the course we talk about simplifying radicals. This is an exact answer. If you were to find the square root of 24, it would be an approximation because 24 is not a perfect square. So I'm going to write down another one. Let's see, x squared plus 20 equals negative 5. I'm going to have you go ahead and pause the video now and try to work that one out on your own. And then when you're ready, just hit resume and my answer will be there. Hopefully you got x equals plus or minus 5i. Now let's go ahead and do a regular, a quadratic equation with an a, b, and c term. We can't factor this because we would be looking for factors of 5 that add up to 4. So we have to use the quadratic formula, the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. You know that we have to identify our a, our b, and our c. And we substitute, so we have the opposite of 4 plus or minus the square root of 4 squared minus 4 times 1 times 5, all divided by 2 times 1. And we just keep on simplifying. The opposite of 4 is negative 4, plus or minus the square root of 4 squared is 16. Negative 4 times a positive 1 is a negative 4, and a negative 4 times a positive 5 is a negative 20, all divided by 2. So now we're going to end up having these two solutions here. So we have x equals a negative 4 plus or minus the square root of negative 4 divided by 2. The value of our discriminant is less than 0, so we know that we're going to have two non-real solutions. We know that this is not going to cross the x-axis. So we can say x equals negative 4 plus or minus negative 1 times the square root of a positive 4 divided by 2. We know that the square root of a negative 1 is I, square root of 4 is 2, so we have x equals a negative 4 plus or minus 2I divided by 2. You may see it like this, or you may see it broken down even further. So it would be x equals a negative 4 plus 2I divided by 2, and x equals a negative 4 minus 2I divided by 2. This can still be simplified. This is the same thing as a negative 4 divided by 2 plus 2I divided by 2. And x equals negative 4 divided by 2 minus 2I divided by 2. And we can still simplify. X equals negative 4 divided by 2 is negative 2, and 2I divided by 2 is just plain I. So we have negative 2 plus I, and we have negative 4 divided by 2 is a negative 2 minus 2I divided by 2 is minus I. You could see it written like that, or negative 2 plus or minus I. It's important for you to understand any way that you could see it and be able to break it down in there. Now, I want you to notice something. We've got a negative 2 plus I and a negative 2, I dropped my minus, a negative 2 minus I. They are opposites. So complex roots are, in this situation, in this example, are negative 2 plus I and x equals negative 2 minus I. Go ahead and read through this little paragraph. So this will happen every single time for complex roots that you have when you solve a quadratic equation. And if you go back and look at our previous examples, it was the same there as well. It was a x plus 5i, x equals a negative 5i, x equals a positive 4i, x equals a negative 4i. It was the same in every single one of them. So let's go ahead and try this one. I'm going to pause the video. You have to use the quadratic formula. There are no factors of 3 that add up to 3. So I'm going to pause the video, see if you can come up with an answer, and then when you're ready, you can unpause it and I'll have my answer up there. So you can see I used the quadratic formula, and I substituted my a, b, and c. I'm not sure why I keep dropping my negatives in here. Substituted a, b, and c, and then used the quadratic formula to solve it. I got down here, and I was able to separate this into two separate fractions and then write my answers. And then this looks very similar to the one that you guys had on your pre-test with the pre-assessment for the unit. So if you have any questions, make sure you write them down and be prepared to ask them tomorrow, and then we'll have some work to do in class.